Now, I just want to say that I was very interested in the historical aspect of this. I've also been to law school, and in those days we used candles and ink and quill. And so I'm going to say a few things right now that, let's say that if you remember them, I'll deny that I ever said them. Okay, first of all, almost entirely the United States rare earth industry is a scam. Okay, most of the people in it have no idea how to develop a rare earth mine, much less process anything. This, where I'm pointing, is the only hope the United States has in the near term of the production of separated rare earths, which can be used to make metals, alloys, and rare earth permanent magnets. This is the only hope. Because you have here a company run by an experienced, successful mining engineer. And you have people here working here who have been working in solvent extraction for what, 40 years? Okay. This is the only the longest experienced solvent extraction engineers in the country, in the continent, I suppose. Well, I don't know how long Canada's been in it. Okay. The point is, this is it. And I said yesterday, this is the chance of a lifetime for you guys. Because if you can acquire the raw material feedstock at a world competitive price, those two little problems, then I know that you will shortly be, well, I understand that in the first quarter of next year, you'll be able to separate the light rare earths from each other. And this involves creating a product we call didymium, which is a trade name for the natural ratio of neodymium and praseodymium in rare earth ores. That is the basis of the modern rare earth permanent magnet industry. I believe that this company will be producing that material in commercial quantities sometime in the first half of next year. That'll make this the first company that has produced this product on this continent in at least a generation. And I know what I'm talking about. I started 61 years ago in this business, and I've been watching for 25 years as the junior mining industry took it over. 10 years ago, we had 250 junior rare earth companies looking at 400 deposits. Most of them were in Canada. Most of those were in Quebec. None of them has ever been developed, not a one. When I was a little boy, the U.S. government set out a prize. They gave $25,000 if you could discover a uranium deposit. So my 10-year-old Jack had a Geiger counter, but there was no uranium in Farmington Hills, Michigan, unfortunately. Okay? But somebody, and I don't know who, maybe you do, somebody in California came across Mountain Pass. And so I don't know how they discovered it, but, there is thorium there, and I guess a little bit of uranium. And they started looking at it. Well, it turned out that it was actually maybe the world's largest deposit of the mineral bastnasite, a rare earth mineral, in one place. I mean, it's a gigantic. I've seen the 3D maps of it. My God, it's a multi-million ton plug of bastnasite. And so in those days, the United States was buying monazite, the mineral monazite, from India and Brazil. And we were processing that here by ion exchange. As a young man, I visited I think it was St. Louis Chemical, which had ion exchange columns the size of silos, and they were using those to produce small amounts of rare earths. Now, I'm talking separated rare earths. There was no market for separated rare earths, for no use for them. The mixed rare earths were turned into metal all together in a mix, and that was called mixed metal. And the military has been using that, I don't know, probably since maybe before World War I, I don't know. And you take the mish metal, put a copper jacket on it, put it in the machine gun belt every 10th round, and John Wayne can track as he's somehow holding a 30 caliber and swinging it back and forth and killing people without breaking his ribs. He could tell where every 10th shot is going. That was the only use. Sometime in the 1960s, when I was in R&D, the Russians, God bless them, came up with the idea of rare earth permanent magnet. They did this by theoretical analysis. They were real good at that. Very, very, very bad at engineering. Very, very good at science. Okay. 10 years later, Japanese Sumitomo started trying to make those. They started making those magnets. In the beginning, they were samarium cobalt. Samarium cobalt magnets were used by automotive beginning in the late 70s. Then in 1980, two gentlemen, I use the term loosely, in London, cornered the cobalt market and drove the price up a factor 4 to 8. General Motors said at the time, I was already a GM supplier then. General Motors said at that time, no more of this. We can't afford the cobalt. The price is variable. We can't do it. Well, at the same time, Sumitomo informed General Motors that we have also a neodymium iron boron magnet, which is probably just as good and has no cobalt. Okay, who's producing the material? Well, there's a company in California, Molycorp. They're producing it. They had made a mistake and built a huge processing plant to produce europium just when the europium market turned. So they finished the plant, and then the price of europium went down by a factor 8. So, wasn't much use for it. Anyway, so they started making neodymium iron boron magnets, and the purpose was to make miniature electric motors so that you could have a car with thin doors, power steering, power seats, power windows. And some of you remember they had radios that where it moved, you push the button and the little indicator moved with a little motor. Okay, believe it or not, a modern car has 25 to 50 miniature neodymium iron boron rare earth permanent magnet motors. Typically, the magnet load in such a motor is grams at most. Your windshield wiper motor, you don't even know what that is, do you? That has about a 2 gram neodymium iron boron magnet. And so altogether, a typical car today, not electric car, or any car, uses about half a kilo of rare earth permanent magnets. Okay, well, Chinese are producing more than enough for that, so nobody cared. And Mark's friend, Constantine Karyanopoulos, about 20 years ago, bought MagnaQuench from its second or third owner after GM divested it to get a whole bunch of money that they needed to correct their lousy management. Okay? So they gave away their vertical integration in the car business. And they said, what difference does it make? Chinese have plenty of this stuff. They'll never learn anything how to really market this stuff. We're the smart ones. Okay, great. So one thing led to another. And the Canadian company Neo Materials, they bought MagnaQuench in 2002, moved it to China immediately. Okay, because that's the Chinese were now producing bastnasite-based rare earths at far cheaper than anything could be done. Molycorp, by the way, had closed its mining in 1997 due to a leak of thorium. Okay, and because the cost of remediating was more than they felt they could ever make by selling rare earths. So they shut that down, and they finally shut the whole thing down. And it was owned by Occidental Petroleum. They had bought, I believe Molycorp was originally a molybdenum company. Okay. So Occidental bought Molycorp, and then they didn't know what to do with it because they didn't want to be in that business. So they merged it with their coal assets at the time, about 2006, and they found an in-house engineer. Well, he was a PE, and he had a law degree, and they gave him the assignment of getting rid of the coal assets, and that included this Molycorp thing. His name was Mark Smith. Okay. I met him about that time. And they managed to sell this company, the largest, certainly known bastnasite deposit in the world. I realize some of you are going to say, wait, the Chinese have got bastnasite. That's a byproduct of their magnetite mining in their iron industry. Okay, it's a big byproduct. But the largest primary deposit of rare earths, I believe, in the world is Mountain Pass. I'll bet. Anyway, so, the second coming of Molycorp was occurring. 4 very large funds, one of them are in resources, bought the company in 2007 or 8, and they paid $79 million. They put $42 million more in to try and bring it back. Our friend, when I first visited the site in 2010, and I was given a tour by our buddy Brock O'Kelly, okay, and I said to him, does anybody in this organization shape yet? Are they old enough? He said, well, they'll be there in a while. He says, you can't imagine the guys would have stuck around 10 years to get jobs back in this thing. Okay. So they were trying to restart the 7,000-ton plant, the 7,000 tons of total rare earth separation, SX plant, right? And Brock told me in the fall of 2010, they had finally separated the light rare earths, and he hoped within a year to do samarium. Okay? That was 2010. In 2011, Resource Capital hired me to do a due diligence on that project. Yes, I've done a lot of crap in my life. So anyway, I looked at it and I said, if I were you guys, I would take it public right away, like this afternoon would be good, okay? Because this is the time everybody's interested. You're never going to have a better time. Okay. And then I made the mistake of saying, and Mr. Smith said, because, I'd been talking to him, and the president of Resource Capital said to me, Mr. Smith is our employee. We run this company. We'd like your advice without his input. Okay. Well, I just still said go public. So remember, they had $122 million in the deal, right? A year and a half later, the company get $8 billion in market cap. Guess what? Those 4 original investors cashed out for $1.8 billion. Pretty good on $122 million, wouldn't you think? Okay. So after that, the thing just ran down. They started something they called Project Phoenix. They weren't going to run the 7,000-ton plant. They were going to build a 22,000-ton plant. Project Phoenix. They had it designed by outside contractors, and when the contractors are done designing it, they presented it to the board, and the board said, okay, we already have a building, so you want to put it in that building. And the then engineer in charge, is somebody I know, said it won't fit in that building. If you try and put it in that building, there'll be no way to service the system. They said, we own the building. This is an economic decision. It's not for you to make. Thus, the difference between a company like Energy Fuels and Molycorp became apparent. The financial imbecile who made that decision wasn't interested in talking to the mining engineer or process engineer who actually knew what he was doing. Okay? Now, so right down the drain, it started to go. Konstantin Karyanopoulos was the president of Molycorp after they fired Mark Smith. They brought him in, and he told me it was like trying to save the Titanic. It was too late. Okay? They ran out of money. The banks wouldn't extend them any more working capital. When they went bankrupt, they had $134 million inventory of cerium lanthanum. Okay? We know now that that was worthless then, and it's worthless now. Okay? But I've never forgot, I looked at the asset sheet on the bankruptcy. I said, 135, what the hell is that? Okay? your government, for those of you who are Americans, your government decided it would buy that. They appropriated $37 million at one point to buy that crap. For what reason, nobody knew. Okay. So I'm just telling you the history here. Now 3 years ago, Mark called me and I said, okay, man, it doesn't matter how many times you flush it. It just doesn't go down. Okay. So I started talking to him and I said, Jesus, this guy actually knows what he's talking about. He's dangerous. Well, hopefully the project won't work, because it'll be embarrassing. Well, guess what? Mark figured out what you have to do and how you do it. And then, I keep telling this story, but a couple of years ago, I called Logan and I said, I need a kilogram of NdPr oxide to show somebody. And he said, okay. I said, how long will it take you to produce that? I know you have a lab. He said, what's your mailing address? I'll send it now. I said, how about 10? It might take a few days. 100? A couple of weeks. Ton? Month, maybe a month. Okay. So I figured out that because Energy Fuels staff did not know you couldn't do that, they did it. Okay? Luckily for them, they didn't know it was impossible. It's like the Seabees in World War II. So I became very interested in this, and over time I've realized that, in my opinion, there's no other company in the United States that could possibly bring this off. The main, one of the main things here is that nobody else can process monazite, because monazite gives you uranium and thorium residue, and nobody else has a license to process uranium or store thorium. End of story. There is no one else. Okay. So now, besides that wonderful little fact, I think that for people I know here and what I've seen, I have no doubt you can produce as much NdPr as you can get feedstock to produce. Okay? I also think that you're going to be very competitive, because typically people who separate rare earths don't make any money. Okay? Mark has actually shipped several tens of tons or hundreds of tons of mixed rare earth carbonate to a customer in Europe at a profit. I guarantee you the Chinese would toast him for that. They can't do it. Okay? And the money is in metals, alloys, magnets. So Mark is already looking at making metals and alloys. There's no secret to it. You just need experience. You can, people who think, well, how hard can it be to make a rare earth magnet? I'll take a horseshoe and wrap some wire. That's not how it's done, okay? It's quite a metallurgical and chemical issue. You have to learn how to do it. You learn how to do it by starting and then learning, okay? These other companies, they're not interested in that. They just say, we're going to make rare earth magnets. No, they're not. We're going to make rare earth metals. Probably not. Alloys? Never, okay? This is going to be a learning process, which I'm sure Energy Fuels is going to accomplish. It's going to take a while. Mark mentioned to you that General Motors and Ford have said they're each going to make 2 million electric vehicles in model year 26. Model year 26 starts July 1st, 2025. That's when you start making 26s. Okay? You need, at the plant, the rare earth permanent magnet motors to be installed in those cars and all the other the gear sets and everything. You need that in the plant May 1st. Okay? Now, this is 18 months now, and there is no rare earth permanent magnet factory in the United States. There's nobody making alloy, there's nobody making metal, and there's nobody producing individual separated rare earths. Do you really think General Motors and Ford are going to make this? And you can say, well, they'll just have to delay. Any of you who has manufacturing engineering experience knows that that motor is just one of 6,000 parts of a car. You've ordered all that stuff, and the big business in Michigan and southern U.S. where they make cars is going to be warehouse space. That's what you want to invest in, because what are you going to do with all those parts? Okay, so right now they're sort of cutting back, and the supply industry's in trouble. The automotive supply industry is in big trouble right now because they're not getting the orders they expected to get. Nobody believes they're going to make 4 million electric cars here with domestic materials in 2026. But that's the goal, and your government says that's what they have to do. Well, the only place I've ever been in the last 10 years that has a chance of becoming a solid part of that supply chain is energy fuels. So I get emails and phone calls every day from people who they got a rare earth project. They got 3 parts per million rare earth at the bottom of the Pacific Ocean. Should I go public? Sure, drop your pants and stand out in front of the camera. I mean, it's ridiculous, but that's what it is. That's how the business goes. This is the only place to look for rare earth production in the United States, probably in this decade. I don't think MP's going to make it. That's my opinion. The rest of them aren't worth whatever you'd like to mention. They're not worth it. And so the market, unfortunately, pays attention to these people, and it goes up and down like I saw an announcement this morning about the discovery of heavy rare earths, which I'm not going to get into right now, in Brazil. And I looked at the numbers. They're pathetic, but it doesn't matter, because the Wall Street boys, and I do mean boys, young people, they'll say, wow, these guys have discovered heavy rare earths in Brazil, and that's going to solve the problem. Not that deposit, but it doesn't matter. They don't know. They don't listen to me. Thank you for listening to me for a few minutes, okay? And if you're going to sue me for libel or slander, I'm 83, so best of luck to you. It takes about 5 years to get to court. Thank you.